Hello again, Methods students. So a couple more sine and cosine graphs with some translations to practice on. This one's example 16. The rule that we're sketching, and it says just for one complete cycle, is y equals sine of x minus pi on 6 plus 1. So first thing to look for in that rule is we know that the x minus pi on 6 is actually going to produce a translation of pi on 6 units to the right, and the plus 1 at the end is going to produce a shift of 1 unit up. So we're taking our basic graph of sine x, right, because we know from this rule that the amplitude is 1 and the period is 2 pi. So basic graph of sine x, but we're just going to apply these two translations to all of our key points. So if we start with the point at the origin, and actually maybe one thing I should do first, with a translation of 1 unit up, that kind of moves the middle position of the curve, or the mean position of the curve, to y equals 1. And because the amplitude is 1, it means that all of our points are going to be, I guess, bouncing up and down between positive 2, that'll be the highest that they go, and 0 along the x-axis here. Sometimes it's not a bad thing to just mark those two lines in very faintly, because it's not really part of your graph, but just so that you know that your curve is going to be kind of bouncing up and down between those two values. So the first reference point at the origin, if we take that point and we go up 1 unit and across by pi on 6, now let's look carefully at this grid. We've got pi on 2 here, so 1, 2, 3 grid lines is pi on 2. So that means that each of these grid lines actually is pi on 6 units. Right, and that's pretty handy, because if I guess a third of pi on 2 is pi on 6. So this point here is x equals pi on 6, so each of these grid lines is pi on 6. Okay, anyway, back to it. So taking our key reference points, we're moving them up by 1 and across by pi on 6. So up 1, across pi on 6 takes my first, I should do this in blue, point to here. Next reference point along the original curve would be this one, this maximum. Again, we're going to take it up 1 unit across pi on 6. Then this x-axis of x-intercept at pi, up 1 unit across pi on 6 units. All right, so you can see we're just building up from our key reference points. Now the minimum at 3 pi on 2. This one again goes up by 1 unit across by pi on 2. So it's going to be here, and we've got 3/4 of a cycle, so let's finish it off. This point here at x equals pi on 2 on the x-axis goes up 1 to the right by pi on 6. And that gives us enough information to sketch one cycle of the graph. Okay, and what you would typically do if it was a question that where your graph is being marked and you've used this sort of original curve just as part of a guide, you would then just, rub out the rest of it that wasn't important, and make sure that what you leave behind is what you want the examiner to mark. All right, and a second one, just to keep practicing the idea. This one's y equals cos of x plus pi on 4, so that plus pi on 4 is going to move the whole graph to the left by pi on 4 units, plus 3 at the end, going to move it up. All right, there's nothing to change the amplitude or period of the graph, so this is otherwise just the graph of y equals cos x in terms of amplitude and period. So cos x has been marked in for us. You can see that's our cosine graph, starts at the top, has a period of 2 pi. And again, all we're going to do is just apply these translations to every key point on this dotted line. The shift of 3 units up takes our mean position to y equals 3, and the amplitude's 1. So again, if it helps you, it's not essential, but you can just do it to kind of make your graph a little neater. You know that the whole graph is going to exist between 4 and 2 and just sort of bounce up and down in between those two values. So that just might be a good little marker for you to begin with. Okay, so to start with the y-intercept, it's at positive 1 originally. We're going to move it up by 3 and then left by pi on 4 units. The grids have been pretty convenient in these questions. You can see that every 2 grid lines is pi on 4, so that means every 1 grid line, every 2 grid lines is pi on 2, which means each individual grid line is actually pi on 4 units. And so when we move left by pi on 4, we're just moving across by 1 grid line. All right, so maximum here, move it up by 3, 1, 2, 3, and then left by pi on 4. That's where it ends up. Take this first x-intercept, move it 1, 2, 3 up, pi on 4 to the left, and so on. This minimum, 1, 2, 3 up, pi on 4 to the left, 1, 2, 3 up, pi on 4 to the left, one, 2, 3 up, pi on 4 to the left. All right, and just for these 2 examples, look, we're sort of just learning the method here. I haven't labeled the axis intercepts, but you saw in the previous example 15 how you can do that, and we might look at doing that in some of the examples later, but just wanted to keep this one a little bit shorter and sharper just to practice that idea of translating the points to build up our sketch.